The universe constantly reveals its secrets to us. Often these secrets are hidden in plain sight. History teaches us that profound truths can be found in the most unexpected places. We only need to observe and question. For centuries, our ancestors accepted ideas that were simply untrue. It took the courage of a few to challenge these assumptions and unveil the true nature of our world. Consider the concept of gravity. Before Galileo, it was believed that heavier objects fell faster than lighter ones. This seemed obvious at the time. After all, a rock falls faster than a feather. However, Galileo's experiments, including his legendary Leaning Tower of Pisa experiment, revealed a different truth. He showed that all objects, regardless of their weight, fall at the same rate, neglecting air resistance. This revolutionary discovery challenged centuries of accepted knowledge. Another example lies in the elegant simplicity of ellipses. Ancient astronomers struggled to explain the movement of planets. They created complex models of circular orbits called epicycles. These models were cumbersome and inaccurate. It was Johannes Kepler who, using Tycho Brahe's precise observations, discovered that planets orbit the Sun in ellipses, not perfect circles. This simple truth had been hidden in plain sight, masked by the prevailing belief in the perfect nature of circles. These historical examples highlight a crucial point. We must be willing to question our assumptions. What we perceive as truth may be based on incomplete or biased information. We must be open to new ideas, even if they challenge our understanding of the universe. The stories of Galileo and Kepler reveal a profound truth about scientific discovery. Sometimes the most fundamental laws of nature are hidden in everyday phenomena. We experience gravity every moment of our lives. It keeps us grounded, literally. Yet, it took the genius of Galileo to see beyond the obvious and reveal the underlying principle. Ellipses, too, are all around us. From the shape of a raindrop falling from the sky to the path of a ball thrown through the air, ellipses are woven into the fabric of our world. Yet it took Kepler's careful observations and mathematical genius to recognize their significance in the grand scheme of the cosmos. These examples demonstrate that the universe is not as complicated as it may seem. The laws that govern the cosmos are often simple and elegant. They are hidden in plain sight, waiting to be discovered by those who possess the curiosity to observe and the humility to question. The key to unlocking these hidden truths is careful observation. We must learn to see the world with fresh eyes, like a child experiencing things for the first time. We must pay attention to the details, no matter how small or insignificant they may seem. For it is often in the smallest of details that the greatest discoveries are made. The scientific method is built on a foundation of questioning. We start by making observations about the world around us. We then formulate hypotheses to explain these observations. These hypotheses are then tested through rigorous experimentation. If the experimental results contradict our hypotheses, we must be willing to discard or modify our initial assumptions. This iterative process of observation, hypothesis, experimentation, and revision is the engine that drives scientific progress. The danger of not questioning our assumptions is that we may become trapped in a cycle of confirmation bias. We may only seek out information that confirms our existing beliefs, while ignoring evidence that contradicts them. This can lead to a stagnation of knowledge and a reluctance to embrace new ideas. One of the most important skills a scientist can develop is the ability to view their own work with a critical eye. We must be our own harshest critics, constantly questioning our methods, our data, and our interpretations. Only by being open to the possibility that we might be wrong can we hope to arrive at a more accurate understanding of the universe. Remember, the universe does not care about our preconceived notions or our desire for it to be a certain way. It simply is. Our job as scientists, as explorers of the cosmos, is to observe, to question, and to follow the evidence wherever it may lead, even if it leads us down unexpected paths. The quest to understand the universe is not limited to scientists in laboratories or astronauts exploring the cosmos. Each of us, in our everyday lives, can engage in the act of scientific discovery. The world around us is teeming with hidden clues waiting to be deciphered. We encounter physics in action every day, from the way light reflects off a soap bubble to the aerodynamics of a frisbee soaring through the air. Consider the simple act of cooking. It's a symphony of physics and chemistry. Heat transfer, phase transitions, the Maillard reaction. These are just a few of the fascinating processes at play when we prepare a meal. By understanding the science behind cooking, we can not only become better cooks, but also gain a deeper appreciation for the intricate workings of the natural world. Sports, too, offer a playground for physics enthusiasts. The trajectory of a baseball, the spin of a basketball, the aerodynamics of a cyclist, all of these phenomena can be understood through the lens of physics. By analyzing the forces, energy, and motion involved in these activities, we can not only improve our athletic performance, but also deepen our understanding of the fundamental laws that govern the universe. The key takeaway is this: the universe is not some distant, unknowable entity. It is present in every aspect of our lives, from the simplest to the most complex. By cultivating a sense of curiosity and wonder about the world around us, by observing carefully, questioning relentlessly, and never taking anything for granted, we can all become explorers of the cosmos, uncovering hidden truths and contributing to our collective understanding of the universe we inhabit.